Hello friends, I am Prof.S.M.Shaikh, Assistant Professor in Electrical Engineering Department. In this video, we shall see a small topic from Unit 4 of EIMT, that is testing of power cables. First of all, let us see the construction of a cable. So the figure 1 over here shows the construction of the cable. You can see this is the center part, which is also called as the core. So this is a modern polyethylene cable designed to be used in a 25 kV system. Here you can see this red jacket. This is known as the jacket or the outermost insulation, which is then which also has a metallic shield or a neutral. It is called, in some cases neutral is connected to this. The metallic shield is applied over the insulation shield and serves several purposes, including providing a path for the flow of charging current, providing a path for the flow of fault current, and reducing the touch potential. Below the metallic shield is the insulation shield, right, which you can see in black color over here. Okay, then there is a thick layer of insulation. This thickness of insulation depends upon the voltage where the cable is to be applied. So more the voltage level it is going to be exposed to, more the insulation thickness will be over here. Then it is also, then there is this conductor at the centermost, which is in this case is a aluminium conductor, which is also which also has a shield around it. This very fine line, the black one which you can see, is the conductor shield. Okay, so this is the general construction of a cable. This is a 3-core cable which can be seen. As you can see, there are 3 cores in this and the individual construction is the same. So again, this is the conductor, then this is the conductor shield, this is the insulation, right? Then again there is the metallic shield, overall insulation, which is the outermost insulation. So these are the different parts of a typical 3-phase EPR insulated cable. Now let us see various causes of cable failure. So broadly, these causes of cable failure can be classified as thermal cause, electrical cause, mechanical causes, then and then there are general causes, which is due to ambient temperature, that is due to environmental condition and parameters such as corrosivity of soil, resistivity of water, presence of UV, etc. Then corrosion of sheath, moisture in the insulation, fire and lightning surges. Okay, so thermal causes, as the name suggests, thermal causes are because of the heating of the cables. Electrical, the maximum operating stress depends essentially on the voltage level, which causes the electrical stresses in the cable. And mechanical failures means due to the digging of the ground, most of the times the cables get injured or get cut. That is the mechanical failures. Now let us see the cable fault location measuring methods. Now since cables are laid underground, that is why first of all it is very important to have method for tracing of cables. So cable tracing is the most important one, followed by cable sheath fault location method, cable identification, twist field location, voltage drop method, acoustic location method, decay method and differential method. Then we have surge current differential method, DCIM, impulse current method, ICM, secondary impulse method, SIM, and multiple impulse method, MIM, fault burn down technology, and time domain reflection method, TDR. Okay, so all these methods we shall see one by one in detail in the next video. Thank you so much.